doing multiplying polynomials, but it's special products. So the answer to a multiplication problem is a product. So 2 times 4, the answer to that is 8. This is the product, right? And this is also going to show you how to use algebra tiles with multiplying polynomials. Okay, next slide. Okay, so we talked about the FOIL method already, and there's also the box method, and then I don't know what you would call the other one. It's like it's distributing and thinking about distributing the first term to everything and second term to everything. Some people call it the rainbow method. But something special is going to happen when you have the same binomial, but it has opposite signs, okay? And so you'll start to see the pattern, and that'll really help you when you get to factoring. Okay, now, whatever method you use, FOIL or box method or first times first, whatever, that we're just going to solve this and see what happens. Okay, so x times x is x squared, and then x times a negative 2 is negative 2x, and then 2 times x is positive 2x. And a positive 2 times a negative 2 is negative 4. And then we combine our like terms, and what's happening? They're disappearing, right? They cancel each other out. They're a zero pair. So x squared minus 4 is our final answer. So this time, when we multiplied two binomials, we got a binomial as an answer. And that was because this is a special product. So what makes it special? Let's go back over that. You have the same variables and the same numbers, but there's one is a plus 2 and one is a minus 2. So let's look at what happens what if they were both the exact same? What if it was x plus 2 and x plus 2? What happens there? Is there something special? So x times x is x squared, and then x times a positive 2 plus 2x. And then this x times positive 2 is another positive 2x. And then we've got a positive 4. Okay, and then we can combine our like terms. X squared plus 4x plus 4. So I kind of wish I would have not used the number 2 now, as it looks as though you're just squaring the 2, but that's not what's happening. Let's try you'll see another example in a minute. Okay, this is another way, another way to write this problem would have been x plus 2 squared like this. These mean the same thing, and this means, actually I'm not going to write it there, I'm going to write it down here. This means the same as x minus 2 and x minus 2. Those mean the same thing, okay? It's not N-O-T, not x squared and then square this. No, that's not what you do. You don't just square, no, don't do it. Okay, because you're squaring the whole parentheses. All right, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x again. And then negative 2 times negative 2 is positive 4. And we combine these. X squared minus 4x plus 4. So that's interesting. We had two positives and we ended up with this. We had a negative, we ended up with that. So that was the only thing that's different. Okay, so you did end up, whenever you have the exact same binomial, you do end up with 3 terms. That special little, it cancels itself out thing only happens if they're opposite signs. See, this is same sign, and then this is same sign. Okay. Now, okay, so let's look for this pattern here, because it might be confusing with the 2's, and you're going to see it with the 6's a little bit more clearly. Y times y is y squared. Y times a positive 6. Y times a negative 6, right? This one times this one. Then this one. Then 6 times the negative 6. I have negative 36, right? And then these two are opposites of each other, so they cancel. And minus 36. Okay. So it's almost as though, now let's point out again, opposite signs, right? It's the same terms, but with opposite signs. And look what happened. You can basically square the first and square the last, put a minus in between. Let's see if it works for this. Okay, so x times x is x squared. X times a negative y is negative xy. Notice I have these in alphabetical order. I'm not going to write y before x. No, no, no. So when I go to multiply y times x, I write them in alphabetical order. And now you can see that those are like opposite terms, right? And y times a negative y is negative y squared. Now these two are the same, and they are canceling. You have a negative one and a positive one. And so your answer is x squared. Oops, not plus. I just automatically wrote the plus, and that's not it. It's negative y squared. So there we go. Okay, now let's see what happens with this. Notice again, it's the same thing. You've got 3x and a 1, and one's plus and one's minus. Okay, so 3x times 3x is 9x. And then 3x minus 1 is negative 3x. Now we're going to multiply the 1 times everything. 1 times a positive 3x and 1 times a negative 1. And now we're going to look at these two and combine them, and they cancel each other out. So you have 9x minus 1. Now take a look here. It's as though you just squared the first term and squared the last term, put a minus in between. Square the first term, square the second term, put a minus in between. Square the first, ooh, we need that square there. Because that was 3 times 3 and x times x, so that gives us a square. So square this term, and you get this, and square this term, and then you put a minus in between. That's the pattern. Okay. All right, so let's see what about patterns when they have the same sign. Okay, now you've got x plus 4 and another x plus 4. Notice I did not just square these, okay? No, don't do that. Okay, you have to rewrite it out and then multiply everything, because those middle terms are not going to cancel in this case. X times x is x squared. X times a positive 4. X times a positive 4 again. And then 4 times 4 is 16. Oh, so look what happened. We're combining these. X squared plus 8x plus 16. So this time you added up, or multiplied by 2, I guess you'd say, the number, and that goes in the middle. You square the number, it goes at the end, and you square the first one. So you square the first one, square the last one, and then multiply by 2 to get the middle term. Let's see what happens whenever you have a negative sign in the middle and it's same signs. So this was plus plus and this is minus minus. I would say always rewrite it, but if you feel like you know the pattern perfectly, then you could skip that step, I guess. So 2m times 2m is 4m squared. So I squared the number, and then the variable got squared. Then 2m times a negative 5, negative 10m. Negative 5 times 2m, negative 10m. Negative 5 times negative 5 is a positive 25, right? Now combine what you can. And we have 4m squared minus 20m and plus 25. Oh, okay. So we could square the first term, and then we could square the last term, right? That middle term, we needed to know that it was going to be these two things multiplied together and then times 2. You could think of it the same way here. Multiply 4 times x and then times 2 to get this term. the pattern is not as helpful whenever they have the same sign as it is when they have opposite signs. Like, I'll show you one more with opposite signs. So x minus, I think we already did 6. Let's do 8. X minus 8, x plus 8. That's going to end up having opposite negative 8x and a positive 8x that cancel. So really, we just go straight to square the first, square the last, minus in the middle. X minus 9 and x plus 9. Square the first, square the last, minus in the middle. It's a difference of squares. That's what this is called, difference of squares. Okay. Now we need to go on to something else. Okay, so we can skip this. Skip that. Okay,